Hey there. In this video, we're going to talk about computing probabilities from the normal distribution. We looked at this in the last video. We computed some percentages from the normal distribution, and you could view those as probabilities as well if you divide them by 100. But we were using the empirical rule, and the empirical rule is a really nice rule of thumb to use when you have a value that is 1, 2, or 3 standard deviations away from the mean exactly. Right? But what if you have a value that's a fractional number of standard deviations away from the mean? Then what do you do? Well, it turns out there's still some stuff you can do here. In fact, we can compute probabilities just fine. We just need the help of a computer. So let's take a look at this. So what we're going to be doing is to compute probabilities, we're going to be finding the areas under the normal distribution curve, because we know that probabilities are represented by areas under the curve. Right? So in this picture here, they're looking at the area to the left of 1300. So that's the probability of getting a value less than 1300. Okay, let's look at some examples of more of this. All right. So here we have cumulative SAT scores are approximated well by a normal model. So they're telling us here, as we talked about in the last slide, that this means that the distribution is normal with mean 1100 and standard deviation 200. It says Shannon is a randomly selected SAT taker, and nothing is known about Shannon's SAT aptitude. Part A, what is the probability that Shannon scores less than 1190 on her SAT? So we don't know anything about how well she'd score, but maybe we can just, if we don't know anything at all, what's the probability that she's going to score less than 1900? Well, let's draw a picture of what's going on, okay? So we know that the scores are normally distributed, right? So we have this bell-shaped curve. The mean is 1100, right? Standard deviation is 200. So right where it starts curving down to curving up, I know that's going to be 200 above and 200 below. So that's going to be 1300 there. That's going to be 900 there. Okay? So these are the SAT scores. She's got 1190. So where is she? She's right over here, right? That's where Shannon is. Okay. What's the probability she scores less than that? I guess we don't know that's where she is. We're just asking what's the probability she scores less than that. That's the area to the left. So we need to get the area to the left of that value. Now, depending on what book you're following, you'll see two different ways to do this. One way to do it, the old-fashioned way, is to compute the z-score and then look that up in a table of z-scores. And they have the probabilities given to you. But nowadays, we have computers that can do this, so that's what we're going to do. We're going to go and use a computer program. We're going to use StatCrunch. Okay, so here we are. Let's see if we can make that same picture in StatCrunch and have it compute the probability for us. So we're going to be using the normal distribution calculator. So I'm going to go to Stat Calculators, Normal. Okay, here we are. And we were told that the mean was 1100. Standard deviation was 200. And we want to know the probability of getting something less than, what was it? It was 1190. So there we are. And you noticed it drew the same picture that we drew. So it looks like it's doing things the right way here. And it's got the area, it's given right here, 0.6736. So that is just what we want. So that's our answer to this first question, question A. Forgot what I read. 0.6736 is the probability. Okay, let's look at question B. What's the probability she scores at least 1190? Well, I think I can use the same picture here because we're still at 1190. So to be at least 1190 means we're on the other side. We're finding the area over here. Okay, so let's do that. Actually, I don't need StatCrunch for this because that is the opposite of scoring less than 1190. And we know that to compute the complement, the opposite, we just take 1 minus this. So what's 1 minus this? Well, there we go. I don't even need to use a computer for that one. We just use the complement rule. What about part C here? We got the probability that, so it says Edward earned 1030 on his SAT. What is his percentile? Okay. So again, we have the distributions. Always good to have this picture in mind so that you can kind of just make sure that things are making sense. Okay. He scored 1030, so that's somewhere down here. What is his percentile? Well, the percentile is the percentage of people that did worse than that, right? So that's going to be the percentage of the distribution that is, this percentage of the area that is over here. Well, let's compute the proportion of the area and go from there. So we will put this into StatCrunch. So we're going to put 1030 in for Edward. So let's go there. It's this same distribution, but I'm going to put 1030 in there. And we're going less than, right? Oh, it already was. Okay. There it is. So we're getting the proportion of the distribution that's less than is 0.3631. To convert that to a percentage, I'll multiply by 100. So actually, I should have rounded 0.3632. And as a percentage, it'll be 36.32. 36.32. So for part C, 36.32 is the percentile that he's at. All right. And finally, D, what proportion of stat takers did better than Edward? Okay, well, the proportion that were less than Edward's score was 0.3632. So the percentage, so the proportion that are greater are 1 minus that. It's going to be 0.6368. Again, if they're opposites, we take 1 minus to get from one to the other. That's the complement rule. Okay, let's look at the next example, our last example today, but it's got a lot of parts, so let's see. Based on a sample of 100 men, the heights of male adults in the U.S. is nearly normal, with mean 70 inches and standard deviation 3.3 inches. Mike is 5 foot 7 inches, and Jose is 6 foot 4 inches, and they both live in the U.S. Okay, so that means that we can expect that they would, belong to this distribution. What is Mike's height percentile? Well, let's see. What's Mike's height in inches? Notice that the mean and the standard deviation are given in inches, so let's write his height in inches. Well, there are 12 inches in a foot, and he's 5 feet, so that's 60 inches, plus 7 more. So that's 67 inches. All right, so we're looking at Mike's height in inches is 67. All right. Now, we want to get the percentile, so we want the area under the distribution to the left of that value. Okay, so let's plug this stuff into StatCrunch. We got a mean here, standard deviation here, and the value we're looking at here, and we want to look at the area to the left of that. Okay, so let's go over there. So the mean was 70. The standard deviation was 3.3. And we're looking at the probability of getting somebody less than 67. And there we have 0.1817. 0.1817 if I round correctly. But I want a percentile, so I'm going to turn that into a percent by multiplying by 100. So 18.17. Okay, so for part A here, we have, can't manage my paper here, the answer is 18.17. That's the percentile. Okay, what about part B? So that's A. What about part B here? What's Jose's height percentile? Well, Jose's height in inches. Well, it's 6 feet is 72 inches, plus 4 more is 76. So Jose's x is 76. And so let's see what we got. What's his percentile? Well, we do the same thing, right? We go over here, but now we're just using 76 instead of 67. And what do we have here? We have 0.9654. I should round that to 0.9655, convert that to a percentage, 96.55. Okay, 96.55. That's the percentile. Okay, let's go to part C here. Eric's height is at the 40th percentile. How tall is he? Okay, so now they're doing this in reverse. They're starting with the percentile, and they're asking for the height. So they're telling us that he's at the 40th percentile. Well, we can just plug this into StatCrunch and have it do the reverse. Okay, so 40th percentile. That means that the probability of having a height less than him is 0.4. And if I hit enter here, it'll give me the height. So 69.16. Those are the inches. So 69.16 inches is our answer here. So for part C, 69.16 inches. D, what is the probability that a randomly selected male adult is at least 6'2" or 74 inches? Okay, well, let's go over there. At least 72. So we're going to put 72 in here and put at least means greater than or equal to, and here we have it. Probability is 0.2722. Okay, so the answer there, I'll just put this here, the answer to part D is 0.2722, I think. Yeah. Okay. What about part E? What's the probability that a male adult is shorter than 5'9" inches? 69 inches. Okay. So shorter than means, sorry, I got to share my screen. Less than or equal to, right? So it actually means less than, but it doesn't matter if it's less than or equal to when we use continuous distributions. So we get 0.3809. 0.3809 for that one. So for part E, 0.3809. And part F, what is that? That must mean, what is the probability that, I think I meant to write, the probability that a male adult has a height between 74 and 69? Well, actually, at this point, we don't need StatCrunch anymore because we know the probability of being, we'll use StatCrunch. I mean, I'll just tell you, you could do it without StatCrunch because we know the probability of being less than 74 is 1 minus the answer that we got for D, and the probability that we have less than 69 is the answer we got for E. And so if I just take the area to the left of 74, right? So that's this area, and subtract the area to the left of 69, that's this area, I will have the area that we want. So I can really just take 1 minus this number to get that first area and subtract this, and that'll give me the area that's in between. So that's what you would do if you didn't have a computer, but StatCrunch lets us do in-betweens, so we'll just do that on StatCrunch. In between 74 and 69, click the between button up here. 74, 69 and 74, I should have said. There we go, 69, 74. And the probability is 0.5063. 0.5063. All right, so there we go, computing probabilities. We went forwards and backwards. Sometimes we were given the percentile and had to compute the value, and other times we were given the value and had to compute the percentile or the probability. Okay, so that's it for this one. I'll catch you next time.